Hello. Before we fill up the room, I would like to ask you some questions. So, how many of you have been at RocksDB Meetup before? We had only one. Awesome. Wow, there's a lot of new people. Cool. Welcome. Hope you got your booze, got your drinks and food.
Speaking to the mic.
1, 2, 3. Better? Cool. How many of you are using RocksDB in production, actually? Nice. Is it working so far? Should we fix something? Are there more people coming in? Couple? Good. Cool. I think we can start. Hello, everybody. Welcome to second RocksDB Meetup. I'm very excited we got you in such high numbers. We have a very interesting agenda today. We're going to start off with some presentations by RocksDB team here at Facebook. So I'm going to first talk about state of RocksDB. What have we done so far? What are we planning to do? And where do we want to take RocksDB next? Usually we will have two presentations, one on language support in RocksDB and another on manageability, how to manage your RocksDB. And then finally, Singh will talk about demystifying options. If you're running RocksDB in production, you probably know what this is. And next up, we have a couple of external speakers. I'm very excited about them. They have sent us slides, but I tried not to watch so it doesn't spoil it for me. So it's going to be interesting for me to see too. So first up, Ankit and Naveen are going to talk about how they use RocksDB in LinkedIn. Next, Mike Lin will present on accelerating genome informatics workflows with RocksDB. And then Andy will talk about looking under the hood with Cockroach, an open source spanner. Spanner is a distributed database, geo-distributed database. And then finally, Reed will talk about building queues that are rock solid and other bad puns, out of context memes, and embarrassing images from his childhood. Cool. So let's get started. I'm Igor, I work at Facebook, and I'm going to talk about state of RocksDB. What have we done so far? What's on our radar next? What are we working on currently? And where do we hope to see RocksDB next couple of years? So what have we done so far? As you might know, RocksDB started off as a fork of LevelDB, and the project started off as like, let's try to use LevelDB for some of our use cases at Facebook. And what we found was that LevelDB was not very performant. It had a lot of stalls, a lot of outliers, and it was bad. But what was good was it was written very cleanly. The code was very, very nice. It had very, very solid foundations. And we loved the LSM idea and the level tree. So we tried to optimize it, and since the code was so nicely written, we could add new features and make it actually work, perform very well for our workloads. So let's go over what changes we made to LevelDB to get to the state where RocksDB is currently. So first thing we did, and what was the most important, was optimizing our workloads and performance for Flash. So if you run your database on Flash, we added some new features like concurrent compactions, universal compaction style, pipelined flushing, with the idea of reducing write amplification and reducing stalls. Next up, we optimized performance for in-memory workloads. So there's a lot of services at Facebook that depend on they're very, very high latency, low latency. They need to be low latency. I'm watching it at a different screen, sorry. So this is for the in-memory workloads. And what we did there is we had to optimize very heavily on outliers. So we had to reduce the time spent when we hold the mutex. So we reduce the work we do under the mutex. and also introduce new table formats and some other features that optimize our performance for in-memory workloads. We also optimized performance for diverse workloads. So there are a lot of, as I said, there's a lot of services in Facebook that use RocksDB, and they have different workloads. Some of them are read heavy, some of them are write heavy. Some of them never use range scans, so we made optimizations for them. We added a bunch of customizations, bunch of options, so each of these services can be configured up for their workloads. For example, merge operators, hash-based mem tables, and so on. We also added new features to LevelDB. For example, column families, which is currently used in some project, is just a way you can partition your database. So you have 10 different column families, means you have 10 different partitions. And we added a bunch of other features like spatial database, backup utility, all other cool stuff that you can use if you're running RocksDB. We also added Java support. So we found out, we hope to add more languages later, and Yusheng will talk about that. But we added Java support natively, so if you download RocksDB from GitHub today, you'll actually, there are Java bindings in there. And we found a lot of people using big data are familiar with Java, so this was a big hit with open source community. I hope some of them are using that too. We also invested heavily in building open source community. So we tried to tend to issues on GitHub. We tried to, review our pull requests. I don't know, manage our Twitter, manage our Facebook group, and we also organizing this meetup. So on the photo down there is there's a photo from our first meetup, and this is our second meetup. So I'm very happy that we see it's the same room. So this is more people now than it was the first meetup, and that makes me happy. And we are hoping to do that in the future as well. We also deployed RocksDB internally. There's a lot of, as I said, there's a lot of services in Facebook that use RocksDB, but one of them that I'm most excited about is Newsfeed. So we just got permission to talk about it today. Newsfeed is a very complex system, and for storage, it used the proprietary storage engine called Centrifuge, and we replaced Centrifuge with RocksDB. And at peak, from Newsfeed, we actually serve 9 billion queries per second. So that's for every person on the planet, one query every second, more. So what are we working on currently? What's our roadmap? One of the projects we are excited about and we're working on heavily these days is Mongo plus Rocks. So Mongo in 2.8 version, which is coming out hopefully by the end of the year, they expose the storage engine API. And we are trying to implement RocksDB as part of that storage engine API. So if you use Mongo, you can have both awesomeness of Mongo and speed of RocksDB. We also have focusing heavily on manageability. So our first feedback, most frequent feedback from our internal customers is RocksDB is fast and so on, but it's very hard to manage. It's very hard to figure out what's going on. And this is what we're trying to tackle. We're trying to make it easier to figure out what's happening in RocksDB, why is it slow, how to make it better, and to make it very, very easy to configure. Another thing we are focusing on and spending our time on is stability. We want to make sure that every release we release to the public and to our internal customers is passing all the tests. We add more code coverage. We are passing all the tests on all platforms. So we have this thing called Tech Dev Week every 8 or 9 weeks, where we just don't do our regular work for a week. We just hack and add new tests, make sure the code is clean and nice. So if you want to contribute to RocksDB today, you can change something and not break everything else. So this is our big focus. If we have a bunch of data stored in RocksDB, we don't want breaking Facebook. That would be very bad. We are also having this experimental project of trying out RocksDB on mobile. So mobile is an interesting use case. Most people are using SQLite, but they're using SQLite for just storing keys and values. So we're trying out what will it mean for them to store those keys and values in mobile. And we are just learning here. So there are different challenges we have on mobile than we have on servers. Of course, like one of them is build size. So we have to reduce what's our binary size if you want to ever deploy on mobile. And we are learning. We are excited about this work. We'll see if this actually turns out to be in production ever. But this is what we're working on currently. And what's our vision for RocksDB? Where do we want to take it in the next 5 to 10 years? So we want to make RocksDB fastest storage engine for next generation. We also want to make it user-friendly. We want to make sure that if you download RocksDB and start using it, start putting data in RocksDB, you can immediately see it's better. You don't have to read books before you can configure it and make it serve your use case. And one of the most important things, we want to build an ecosystem. We want to make sure there are people who know how to use RocksDB, that if your company is deciding, should I use RocksDB or should I use something else? They said, okay, I might use RocksDB because first Facebook is using it, but not that's the only reason. I also want to use it because there's support, there's people on the job market that can hire that know RocksDB, there's other companies that are using it, and I can call somebody and ask, hey, this is slow, can I make it faster? Or hey, this corrupted my data, why? So if we build ecosystem, we'll also build trust, and we'll make RocksDB better for us and for everybody else. So thank you. This was my presentation, and I'll give it to Yusheng, who will talk about manageability and Java support. Thank you.
Can everyone hear me? Okay, cool. I'm Yusheng from Facebook RocksDB team. So today I would like to talk about our vision and progress on language support. So as you may know that RocksDB is a high-speed embedded key value store that is written in C++. It is a C++ library that you can use as a building block for your application. But however, it also means that if we don't do a good job in language support, then you will not be able to use RocksDB in other programming languages. So earlier this year, we start our effort on making this better and start building a bridge to Java to make RocksDB available in Java. So now I would like to announce that RocksDB is available in Java. So we built an official Java binding called RockJava, which is implemented using the regular JNI stuff. So RockJava have three goals. So first, we would like it to be performance comparable with RocksDB C++. RocksDB is well known for its high speed. So when building a language binding, performance is definitely our first priority. And second, we would like RockJava to be feature comparable with RocksDB C++, such that whenever we have a new feature in C++, it will be available soon in the Java world. And third, in the future, we are talking at having the same release schedule in both languages. So whenever we have a new feature, it will be available on both C++ and Java in the same release. And let's take a look at some examples showing how to use RockJava. So first, let's take a look at how to open and close a DB using RockJava. So first, you declare a RocksDB variable. And then, as we did in the RocksDB C++, we will create the options class that allow you to configure that to be open RocksDB. So like, for example, here we set create if missing to true. Then create the RocksDB instance. It's as simple as calling RocksDB.open, which inputs an options object and the path to the DB. We use the regular Java extension to handle any potential errors. And finally, to close the DB, simply call the db.close. This will close the RocksDB and also release its associated C++ resource. Because RockJava is implemented in JNI, so every Rocks object will associate with some C++ resource. So here it is suggested to call the dispose manually to release its C++ resource. But in case you trust the Java garbage collector, we also implement RockJava in a way that all the C++ resource will be garbage collected by the Java garbage collector once it goes out of scope. And here's an example showing how to do write and read from the database. To write to the database, we use the API called put, which inputs two arbitrary byte arrays, and one for the key and one for the value. We offer two flavors of get. The first one, it allows you to read without a pre-allocated buffer, so that the dbget inputs a byte array to specify the key, and it will create and return a byte array filled with the matched value. Well, oftentimes, you may prefer to use the second approach, which is read using a pre-allocated buffer, so that this get take two arguments, one for input the key, and the other one is a write buffer that receives the return value. This function returns the length of the value, so you know that how many bytes you need to read from your pre-allocated buffer, or you can also tell whether the size of your pre-allocated buffer is big enough. So here's some timeline about RocksJava. We started this project in this February, and in March, we have most basic DB operations ready, such as DB open, close, get, put, and delete. And in April, we start adding some utility functions such as statistics and backupable DB support. And in May, we have iterations and Java DB benchmark already, so that at this moment it's mostly feature compatible with RocksDB release 2.8, which is everything before column family. And in June, we start adding restore backupable DB support. So during the early development of RocksJava, Facebook and LinkedIn are the two major contributors. And what made me feel very excited about this project is that starting in this October, we start receiving external contributions from open source community. So in August, we have slice, basic custom comparator, and default merge operator support ready in Java. And in September, we start having basic column family support and snapshot support, and up to now, we have full column family support in Java, and also some new features such as rate limiter are also available in Java. And here I would like to give special thanks to Mr. York Mayer, who is probably well known as his name, FYRZ, who has been actively contributed to RocksJava, and also developed full support of column family support to RocksJava. I would also like to thank Adam Ritter, who adds support for slice and basic custom comparator. And I would also like to thank Valet, who adds support for default merge operator. And here I would like to show some performance comparison on RocksJava and RocksDB C++ on Flash. In this benchmark, we consider 1 terabyte database, where the database size is greater than the cache size, and all the workloads are IO bound. Our result shows that the RocksJava is performance comparable with RocksDB C++ on IO bound workload. Well, while we have developed a visual binding for Java, there are other many popular programming languages such as Python, Go, and Perl. So we would like to thank for the open source community that developed these many third-party language binding for RocksDB. In case you would like to develop your own binding, we also have the RocksDB C API that allow you to build your language binding based on this. And next, I would like to talk about our current plan and what we are currently working on RocksDB manageability. When we talk about RocksDB, the first impression you might have is RocksDB is a key value store that runs in very high speed. And we also develop RocksDB in a way that is highly configurable to be able to fit into different server workload. But this flexibility also means that it gives you more responsibility. And oftentimes we hear that when a developer first uses RocksDB, oftentimes it is overwhelmed by the so many options that we offered. But here I would like to say, don't worry about this. We know this, and we are working hard on this, and here are the cool stuff that we are working on. The first cool thing that I would like to introduce is we are trying to make options easier to tune. So for example, we add couple helper functions that allow you to tune RocksDB be a good enough state by calling one or two function calls. Like for example, here you can call increase parallelism, or you can simply call optimize level style compaction. So that is the easiest way to tune RocksDB to a good enough state. We also have a RocksDB performance tuning guide, so that in the guide we use a purpose-driven way to tell you, for example, if you're working on if you're focusing on redundancy or workload, then here are a set of options that you should look at. And the second thing we are working on, we have been done, is we allow the options to be dynamically changeable. So oftentimes when you build your application on RocksDB and start running your service, and at some point you would like to tune RocksDB further. So what you previously do is you close the DB and change the option and reopen the DB once again. And now we make this option dynamically changeable such that you can use this set options API and set the database options without closing the DB. And we also document the options in a way that you can easily tell whether this option can be dynamically changed. And then we are also currently working on exposing the thread status. So oftentimes when you run RocksDB, you would like to know whether RocksDB is doing a good job. For example, you may want to know how many threads are currently doing compaction, and how many of them are currently writing to a file or waiting for a mutex. We are currently developing the get thread list API so that you will know the list of RocksDB thread and have a better understanding on what they are doing, and probably give you some hint about how to tune RocksDB further. And thank you. Then I will introduce and talk about RocksDB options.
Hello, everyone. My name is Siying. I'm here to talk about RocksDB options. I'll try to show you that RocksDB options is not something you should worry about. That should be straightforward and simple. Here's the agenda. I'll talk about the mystery that RocksDB options appears to many users. I'll introduce a new feature, LevelDB compatible options, and I'll give more introduction to RocksDB options. So I hope after this session you will realize that you don't need to worry about RocksDB options at all. It just works fine without your knowledge of most of them. So why we call mystery to RocksDB options by some users? This is a simple list of options. Simple and easy, but that is for LevelDB options. This is RocksDB options. So I hope you're not scared by the number of options of RocksDB, but after this session, you will see without knowing most of the options is for RocksDB should just run fine and performance well. So LevelDB is easy to use, appears to be easy to use, but RocksDB is good. RocksDB is good for server workload. Its performance better. It has less performance outliers. And it's more reliable, has a lot of new features. But can RocksDB be as easy to use as LevelDB? So actually, you can use RocksDB just as using LevelDB now, using a new feature called LevelDB compatible options. Here is a sample piece of code for LevelDB. In here, you create an option object and set some options and open a DB using the options. This is LevelDB code. you can simply turn it into RocksDB code and open an RocksDB instance. What you need to do is to replace the option object to a LevelDB options object and call a function called convert options to convert the LevelDB compatible option to RocksDB options and use that one to create the RocksDB to create a DB. So by using that, RocksDB should just work fine to you. And for most of the users, the performance should be fine. That should satisfy your requirement. Well, but in case for some users, there's some special requirements, have very special workload, and you want to further tuning it to get it better. So the next session is for you. In the next session, I'll introduce RocksDB options, and you will also know that for most of the users, you don't need to know about this one, about them, and the default value should work very well for you. So I grouped those options to 7 categories, and I'll go over them one by one. As I said, the default value should be fine for most of the users. But RocksDB has some good features, like the merge operator is very popular among our users. It allows you to avoid I/O when you do the write after read operations. And it has a popular compaction filter, can help you to implement TTL features efficiently. But how you can make use of them, you have to through its options. So some of options are used to enable and configure those new features. All those features are opt-in. You don't have to use it unless it is really good for you. And now, after you run RocksDB for quite a while, you are interested how is going on inside and how many IOs it does to your storage and what's the latency of a read-write. And we have a feature to expose those statistics to you to allow you to know more about them. And those operations and those options are for you to know more about RocksDB inside. No, this is gone. And now you are an expert on RocksDB, and your requirement is your use case is kind of special. For example, you might use pure memory use cases, or you may use it in a hard drive and have IO budget very tight. We make a lot of components of RocksDB pluggable just to this kind of special use cases. We have a different plugin of mem table, SST table format, and compactions to different kind of special use cases. And those objects are for you to enable those different plugins for your very special workload requirements. This is gone too. So you have your special use case in another way. You might use it in a cache or a temporary storage, and you don't care about the full persistency of your data, and you wonder whether you can turn off some of the reliability features so you can get a slightly better performance, and those objects are for you to try. You can turn off some of the reliability features like checksum and see whether performance can improve. In most cases, it probably doesn't actually. And now you are an advanced expert on RocksDB. And you know that RocksDB runs on LSM, and you say, okay, how if I tune the shape of LSM? Can RocksDB performance better? Can do it better read amplification, write amplification, or space amplification? And those options are for you to try. There are quite some options, but the most important ones are the 3 ones I listed in red. Those 3 are mostly determine the shape of the tree, and will determine the write amplification, read amplification, and space amplification mostly. So it is gone too. Now you are a super expert on RocksDB. You know all the details of RocksDB, every component. So now you start to get some crazy idea to say how if this component do in another way and this component in another way, how it might be better for us to blah blah blah, and these options are for those advanced users to control the behavior of some components to do differently. You can control the way RocksDB to communicate with file system, to control how RocksDB writes to Red Hat log, and you use the resource. And those options are for those really advanced users who wants to tune RocksDB to an extreme. Okay, this is gone. Last pieces are mostly for fun. If you are a developer and you want to just catch up a benchmark for 0.5% whatever, you can try out those very very hacky parameters in some corner of the code base. So in most of the users, you don't even need to know what they are. So that is all the RocksDB options explained. As you know, most of them, you have nothing to do with them unless you have very special requirements or you have special hobby. You don't need to worry about these options at all. So in this talk, I introduce LevelDB compatible options, a new feature to allow you to use RocksDB in the same way as you're using LevelDB. And I explain the categories of RocksDB options, and you should now know that you should not be scared by the number of options by RocksDB. It should be all fine. You just forgot about it. That's fine. And finally, we have a RocksDB tuning guide. If you want to tune RocksDB, you can go there as a start. Thank you very much.